Okay, now what's the slope of PQ? We should have it right here. Here's the rise and there's the run. So P is going up 15 and over 5. So the slope is 15 over 5, which is 3. And it's going in the positive direction, so it's positive 3. Okay, what's the slope of QR? Right there's Q and R. There's the rise is 4 and the run is 9 and it's slanted down. So the slope of QR is rise of 4, run of 9, slanting down. Are they perpendicular? They are not perpendicular because they're not negative reciprocals. They have to be negative reciprocals to be perpendicular, which is the answer to number 7. What must be true for them to be perpendicular? They have the slopes. Let me write the word slope. So you should have it something that says the slopes must be negative reciprocals. My new pen doesn't really like to write. Negative reciprocals. As an example, the 3 would have to be, the negative reciprocal of 3 would be negative 1/3, and the other one, negative 4/9, negative reciprocal would be 9, positive 9/4. So write an equation of PR. Right there's PR. Doesn't say what kind, so probably the easiest way is to just deal with it as point slope. How about I just pick that point right there? So point P, that was point P. So I'll just go y minus, and the y value was negative 8. So it's going to be y minus negative 8, which will make it y plus 8 equals the slope. Okay, the slope, rise is 11, the run is 14, and it's in a positive direction. So I've got 11/14, and then x minus the x value. The x value of that is negative 8. I have that backwards, don't I? The y value was down 6. So y minus negative 6, that should be y plus 6. And then describe a different equation. Well, you could just do it off the other point. The other point up there off of r. So it would be y minus the y value 5. Same slope. And then x minus the x value, which was, what was it? 1, 2, 3, 4, 5, 6. Is 0.22 on there? Kind of looks like it from the graph, so we're going to have to do something other than just looking. So 2, well, I can just stick 2 in there and see if it actually makes the equation work. You can pick any equation you want that describes that line. So I'll just pick this one right here. So y is 2 and x is 2, and it has to make it true. So if I stick the 2 in for the y, it's 2 minus 5 equals 11/14. Stick a 2 in for x, minus 6. That has to be true. If it's a point, it's going to be true. So 2 minus 5 is negative 3. Is that 11/14? Of 2 minus 6, which is negative 4. Okay. That does not multiply together to be negative 3. It becomes 44/14. So the answer to that one is no. When we plug 2016 in there, let's take a look at 2016. I'll put the 16 in for the y. Is 16 minus 5 equal to 11/14? Put the 20 in for x, that's going to be 20 minus 6. So 16 minus 5 is 11. 11/14 times 14. So that 14 is like 14 over 1, so those 14s actually end up canceling out, and we have 11 equals 11. Since that's true, that answer is yes. So explain how you can tell if a point is on PR. You would just write this in a sentence. I'm not going to write it since I can't get my pen to work all that well. Is you plug in the point and see if the equation is true.